right, so pressure control valves. Okay. So there's many purposes of pressure control valves. You have things for unloading the compressor. Now what we mean by that is basically taking the compressor and decompressing it. Why would we want to do that? Well, if you've got water in your compressor, and it does happen, this is Alabama after all. What do we have plenty of in the summer in Alabama? Humidity. Has everybody grown their gills yet? I think we got to heal them up in the winter and then we grow them again in the next summer. That's the only way you can breathe the air outside is to have a set of gills. So, yes, periodically you do have to empty a compressor. Why? Because if you don't pull all the water out, the inner tank is not meant to hold water. What does that create when you have water and metal? Rust. Not something we want. So we do periodically have to drain the compressor and make it to where it's safe again. We have pressure regulating valves. This is to reduce pressure to a level safe for equipment operation. In other words, we use pressure regulation to make sure we don't overload our system. If you overload a system, hydraulics or pneumatics, you're begging for trouble and it will find you. Safety valves open at a preset pressure and exhaust until pressure drops below preset. What that means is that if you have your system set for 90 psi and this thing's reading 100, it's going to open up, and if it's pneumatics, it vents. If it's hydraulics, it pushes everything to tank. Okay? That is its purpose. And it does so until it either hits 90 or below 90 so that the system can repressurize. Okay? Relief valves open proportional to the pressure. And have to be sized large enough to discharge more air than the compressor can supply. Safety valves and relief valves kind of go hand in hand with all of this, simply because you don't want to be without. Hydraulics, you're liable to blow a line. Pneumatics, well, most of us tend to think pneumatics are safe. They're not. Because if a hose gets loose in pneumatics, what's it going to do? It's going to be one of those wacky wavy. Yes, thank you. Oh, it'll hurt. Especially if you catch it across the base or anything else. Those things can crack like a whip. And they can take out an eye, they can take out, let's just put it this way. How many of you have ever had one of those towels and you snap them at somebody? Well, if you snap it hard enough, what happens? You snap it hard enough, you can leave a welt. These things can snap hard enough to leave that and more. You don't want to be in front of them if they're snapping around. So.
Well, how about if you like the only way to stop it though is to go next to it because your hose is right there next to the regulator. So long hose, it's just go like right next to it. You just have to go down there and turn off that, or do you just send it and you just like close your eyes?
Well, I'm glad you asked that because as far as most systems go, I don't know if this is all systems, but a lot of systems have safety relief valves every so far. And if it's not a safety relief valve, they at least have a shutoff valve. So each of your trainers has a shutoff valve above it. You have all sorts of ways to stop air from going. If you have it in a certain system, are what we call work cells. And those work cells are particularly set up to make one type of product at a time. Those specific cells are also going to have their own safety gate for the air or hydraulics that they use. Why? Because that way, if it's not in use, they're not putting air to something that's not in use. But it also makes it to where, let's say, a pipe burst or a hose comes completely loose and starts going ballistic. I don't have to get in that area with that bad component. I can shut it off from outside. That's safety measures. That's something a lot of people put in place to make sure that they don't have that problem. Does that make sense? It's one of those things of here's the biggest rule about safety. And it's not what you think. The biggest rule of safety, and this is a just about hard and fast fact, you'll find it everywhere. Safety rules do not change until someone is hurt or killed. That is across the board, just about the most hard and fast safety rule you'll ever find. Is until somebody has been injured or killed, laws don't change. Rules don't change. It doesn't matter if somebody sits there and goes, oh, that cord on the floor is really, really dangerous. We don't need to trip over that. We don't need to be stepping on it. We don't need to be doing anything. Hey, boss, can I bury this in the floor? Or can we put something over it so people aren't stepping directly on it? No, that'd take too much money and too much time. And that's the same response you would get all the way up until what? Something really negative happens and somebody's about ready to sue the company. All of a sudden it becomes a big thing and everybody sits there and goes, well, why didn't somebody say, let's bury this thing? Why didn't somebody say, let's cover it so nobody trips over it? At which point you're the person that gave that advice and you're going, I told you so's are not your boss's favorite thing to hear. I hate to tell you. Doesn't matter how many times you tell your boss something, it's not going to be your idea. And I told you so is never something you want to say to your boss. They tend to resent that for some reason. So safety problems don't get solved. It's one of those things of squeaky wheel gets the grease. Y'all know what I'm talking about? Well, actually, two things can happen to that squeaky wheel besides it getting the grease. It can also get the boot, right? So it's one of the things you always have to balance. And when it comes to safety, not everybody wants to hear it. So we have what are called poppet pressure relief valves. These look kind of similar to what you would find on air tools. Okay. They make a couple of different ways of doing this, but you have adjusting caps, you have a lock nut, a valve, and most of the time it is a check valve. Why would we put a check valve in there? Well, because we don't want air being forced back to the compressor, because that could really cause some problems. Okay. So we have y'all don't have to really like memorize this, but this is just to kind of show you there's different types of relief valves. These have what's called a diaphragm in them, and the diaphragm works a lot like the check valves as well. The main thing is that you never want pressure going back to the compressor. Why? Because how many of y'all started messing with those motors and figured out what back pressure is? Back pressure is not a bad thing, but it's not a good thing. Because back pressure happens, let's say you have a double acting cylinder.
Isn't that like a backfire in the car, or is that not?
No, it's the prank that everybody tries to play with the fruit, potato, what have you, in the car exhaust.
Um,
Okay? So, whenever you're using a double acting cylinder, this is what you're actually kind of playing with, is this guy right here. So, whenever you apply air here, you're putting all this air in here. Okay? Y'all with me so far? However, you also have air pressure up at the front part of this cylinder. Why? Because there was air there previously. Okay? Now, if I put my flow control valve on both of these, we're going to talk about the two different ways we can do this. One is called what's meter out. We're going to talk a little bit more about that in a minute. But with meter out, what you do is you put a constriction on these exits, not on the entrance. The air can go in all it wants to, but you control how the air exits from your actuator. That's the word. You control how the air exits. So think of it like a giant amphitheater. Going to a baseball game, football game, basketball game, baseball game, going to see a movie, what have you. Okay? So it's easy to get in only by how easy it is to get out. Okay? So if you've ever been into a movie theater before the movie ends and you see all the people there, okay? How fast they can leave and you can take their seat is dependent upon what? Size of the doorway. Huh? The size of the door. If you have one single little bitty inky dinky door that everybody's got to go through and you have, let's say, 200 people, that's going to take a while, right? You'll see where I'm going? It takes a while to get the people out, so thus more people can't come in. That's why in a lot of theaters you see everybody has double doors and more than one entrance. Why? Because it allows people out faster. Y'all following? The same thing happens with these relief valves and back pressure. What I've just described to y'all is what back pressure essentially is. What it is that you have air pressure that is still in these cylinders, that is sticking around. Okay? What that means is that when the air tries to leave versus the air trying to enter to push the cylinder back, you can only fit as much air in here as much air as is leaving from here. If I can get the words out of my mouth without tripping on them. So in other words, it doesn't matter how much pressure I apply here, the pressure back here can't be forced out of the opening any faster. Okay? And what that would do to it, what would that do to a compressor? What do you think? Well, it can, at the very first part, you're probably going to start really expanding that tank, and you have pretty much created a pressure bomb. Not a good idea. How many of you ever watch YouTube videos where somebody's really stupid and puts dry ice and water in a Coke bottle? Anybody ever seen that experiment? It's not a good experiment to do because it's actually going to be really dangerous because you get plastic shrapnel from that. But and it is not something I encourage you not to go do it. Yeah, there's all sorts of ways to make pressure vessels. One of the most dangerous lies in your house, and that if you've ever watched the Mythbusters, you know exactly what it is. It lies in your basement, or at least it's some way tucked away in a closet. It's a hot water heater. You disable the safeties on one of those suckers, you're gonna lose your roof. Pressure vessels are interesting in the fact that if you use them right, you never have an issue out of them. However, if you start disabling safety devices and you start disabling its ability to save itself, aka you put a cap on a Coke bottle after you put something that's going to expand quickly in it, you've created what's known as a pressure bomb, and it's not a good thing to have. It's something you want to get rid of very quickly because once it goes, it's going to put shrapnel everywhere. Like I said, that is not authorization for you to go do it. I did not tell you to do so. If you really want to know what happens, watch somebody having already done it on YouTube. Do not come into class missing a hand. And yes, I am serious about that. Do not come to my class missing a hand just because you decided to go do something silly. Pressure regulators, so this regulates the output pressure and automatically closes when the pressure goes up and opens when it goes down. So what this is supposed to do is, how to say this differently? We don't want excessive pressure, but we don't want low pressure. If we have too little pressure, what can be a problem with too little pressure? Our devices won't work properly, yeah. And if I have too much pressure, you're going to bust something. So we have to keep it between the lines, right? It's sort of like when you're driving. How many of y'all actually set this cruise control? Every time you're on the highway. At exactly 70 miles an hour. How many of you know what the minimum speed you're allowed to be on that interstate at?
55? I think it's 45.
40 in most places. No off-road vehicles are supposed to be on the interstate. I think the only thing that you are allowed to put up there that's something like that would be a truck.
Or a razor, though. Because you can make razors too legal. You can like 80s.
Technically, you could put a moped up there, but I don't think you'd want to do it. Not so much for the person that gets run over on the moped. Mm-hmm. Please tell me you were not part of main traffic. That you were on the shoulder. Because that would not be very good. You get hit by an 18-wheeler, you're not going to be. You're not going to live if you get hit by an 18-wheeler on the interstate. I don't care what you do it. All right, I'm going to move through some of these. These are just different pressure regulators. What they're meant to do is exactly what they say they do. They control the pressure, and what you want to do with these is have control of that pressure. Let's talk about service units. Now, service units are probably one of the most common things you'll come across that have pressure regulators. Why? Well, because they are the ones that control what goes in and what comes out of those valves. And instead of drawing big versions of these, we tend to want to contain. And this right here is what you will see in a blueprint of what a service unit should be. And they simplified it to what it is. One of the things they put in there is the fact that you've got a drain. You will always have, especially here in Alabama, good Lord. Since we carry so much moisture in our air, that there is quite a good chance of it passing through the compressor and into its lines. Just about every unit has one of these. some way to pull the water out of the air and push it out to wherever it needs to go. You do not want it in your system. It's bad luck. Because let's just put it this way. If moisture gets in here, you think you're ever going to get it out? No. Moisture gets in your actuators, it's toast. It might not be toast that day, but the rust is going to start, and eventually it's going to kill it. That's why we try and pull the moisture out before it gets to something like this, because there's no way to disassemble these. I'd love to see somebody try, because there's no way. There's no way to save it. Yeah, but except for one problem. You've now introduced a structural weakness.
Yeah, I'm with you on that.
And structural weaknesses,
Well, I'm on dirt bike frame. I had to weld my frame together.
that is something totally different.
But wouldn't that be weak though? My frame?
It depends. Most of any dirt bike or bicycle, motorcycle, what have you, a lot of that is already welded anyway. And if you know what you're doing with that weld, that's one thing. However, you're talking air going through these cylinders or liquid. You've got pressurized fluid power.
Well, wait.
And if that weld is not strong enough, if it's weak or it has any kind of little hole in it, I wouldn't trust it.
But you got companies that, yeah, like my company, we send our students out and get it fixed. Well made. But I know what you're saying. If it's weak well,
Yeah.
it is.
Let's just put it this way. You don't want. You have to Nope. Rigorously test things like that to make sure that you're not going to get fluid leaking out of it, that it's not going to be a big issue. Because what can happen is, let's say one of these has a pinprick hole in it. Over time, that hole's going to get bigger, first of all. Second of all, that air is going to be escaping from that hole a lot.
They make them like that.
Yeah.
Like
if you look at these over here on the table, and I'll let you look at those in a little bit, those are sealed. And there's a reason they're sealed. Is to keep, okay, so you can't really see it well. There's a seal around these. That's to keep the pressure in it, but also to keep dirt, debris, and everything else out of it. Because what it does is that this thing is refracted, it wipes any dirt and debris and lint off of it, so that every time it extends, it looks like new. That is the purpose of that. That's a wiper. So if you have holes in this, you're inviting more trouble than you think. Okay. So that's why we put drains on a lot of this, is to keep moisture out of these, because it will just absolutely ruin them in 5 seconds flat. Other thing we use, 9 times out of 10, you'll have a pressure gauge attached to the system. Why? Because let's say one cell needs 90 psi, another cell needs 120. Well, you gotta be able to set it differently. What is generally recommended besides your pressure gauge and your regulator is a lot of the times some sort of an oil set, because what that's supposed to do is that it adds oil around these actuators. The oil is a good thing because it means that it prevents rust. Excuse me. It prevents rust, and it also keeps everything moving smoothly. Sort of like, why do you put oil in your car? Keeps everything running smooth. And lubrication also helps with one other thing. What is it? Friction. The one thing that is the enemy of all mechanics, right? Friction is bad when it comes into contact with mechanicals because it causes damage. All right, so let's talk about fluid flow control. So both use fluid control. You don't talk as much in the book about pneumatics. So an actuator's area and fluid pressure determines the force. We've talked about that quite a bit. The power source's flow rate determines the actuator's speed, which is what we talked about with the last problem we did. The flow rate is determined by the pressure and the opposition in the system. So how many of you take electricity or know anything about circuits of some sort or another? All right, so these are just another form of a circuit, okay? If you kind of keep that in mind when you're working with them, that's all it is, it's a circuit. If you worked with them once, you can work with them again. So let's talk about the three different types of ways the two main types that we control flow, and then you have what's called bleed off. So meter in is regulating the pressure that goes into your actuator. Excuse me. Allergy season. So meter in regulates the pressure that goes into an actuator. So that means that any and all pressure, when this comes back, it's just going to go straight through the check valve and just say bye. It doesn't hold. Okay. You have what's called meter out, which is what we've already talked a little bit about. Meter out controls the air that is coming out of the actuator. It doesn't care about the air that's going in, it cares about the air that's coming out. Does that make sense? Everybody with me so far? Okay. And these are two very important things. We'll talk a little bit more about them. Then you have what's called bleed off. So what that does is, how many of you have ever had to bleed your brakes? Y'all know what bleeding your brakes is supposed to do, right? Remove the air, because why do you not want air in your brake lines? Air compresses, fluid does not. Can you imagine what would happen if you have air in your brakes? You ain't gonna stop. It's kind of like in the movies when somebody supposedly cuts the brakes. You see the guy like, stomping on that brake hard as they can, right? That's pretty much what would happen in reality. That's why you bleed your brakes. You do not want air in your brakes lines at all. That is really bad luck. Okay. So it bleeds off excessive fluid circuits where only a portion of the main fluid is required to control the actuator. Okay. So these are familiar because you've seen them using the needle valve, pressure control valves that we've been using. Okay. And here's a different kind of look inside a pressure control valve. This one's kind of a pressure compensated. Okay. So it's got a dampening orifice, it's got the fluid outlet that's regulated, inlet. They've got everything labeled here right now. I'm trying to figure out exactly where they're thinking everything is. So this is your fixed spring. So if you ever have fluid that's trying to come through here, it's able to push. It can't push against where the spring is. Okay. So fluid has to only come through one way, unless it's able to push this back against the spring, and then it can exit through here. It looks like everything's got to go through a fluid inlet. Or, sorry, the regulation inlet. There's one that's set up as a bypass. So that's draining everything to reservoir until it's actually actuated to move everything through it. Fixed orifice versus an adjustable orifice. I don't know who drew that. All right, let's get to where we need to be. All right, so meter in means that I've got constriction on what's moving into my actuator. Okay, I've got control of the fluid into the actuator. All right, so this one is putting it into a motor. Now, real quick, what is the difference between the symbol for a motor and the symbol for a pump? Anybody ever take blueprint reading? All right, y'all should know this one then. What is the difference between the symbol for a motor and the symbol for a pump?
A motor has an end usually.
Not this kind of motor.
Or it only shoots out forward.
All right, so the motor is something that if it's a fluid power motor, it's accepting fluid into it. Okay? That means the arrow points into it, into the symbol. A pump is pushing fluid out of it. So thus you have it pointing out. That's the difference between the two. Probably a good idea. You might want to write that down. That'd be a great test question. What is the difference between a pump and a motor on the symbols? Well, they both use energy, technically. A pump is using electricity to create energy. A pump has stuff flowing through it.
Well, I know. I'm saying, like, I guess I was thinking about pipe.
Yeah.
Because it doesn't.
Well, if you're thinking pipe, then you're right. It's something that's got something flowing through it. But with a motor, it's using that fluid to turn itself, right? With a pump, it's pushing the fluid through it. It's pushing the fluid into the system. Okay. Everybody good? Yes. All right, so this is meter out. So again, meter out is all about controlling the fluid flow out of your actuator. So in other words, it's like a concert. Anybody, if y'all have ever been to a concert? Okay. How many of you have ever been to the Oak Mountain Amphitheater? A couple of y'all? All right, so if you're at the amphitheater, right here you have these giant gates to let people in, but over here you might have a little small gate to let people out. So if you have two concerts, one after the other, this is meter out, right? You can imagine what's going to happen. People are trying to come in so that they can sit down for their concert, but the amount of people able to come out, they can't leave fast enough for the people that are coming in. So it creates a backup, right? That's the simplest way I can explain meter out. That's the best way I can explain it. This is about the only. I can't think of another real world example besides like a movie theater or an amphitheater. Can y'all? Ooh.
Horse races, but same thing.
Yeah. Well, I'm thinking of how many of y'all go shopping on Black Friday? I got one person. Nobody else has been. You've been. All right, so nobody's crazy enough to go shopping on Black Friday. Good. That means everybody lives. God, I don't want to even think about the gonna be like this here. But if you go someplace like Target or Michael's, whenever they first open those doors, do they open a bunch of them at once, or do they open a few? They open very few.
Yeah, I'll be at Target.
No, there's a worse one. Every year in New York, they have and I only know this because I ended up seeing a commercial for it the other day, where apparently they have all these bridal dresses, and everybody stampedes this store to get to the bridal dresses because it's the one day that they have them for really cheap. And people have killed, these women have killed each other over wedding dresses. It's getting crazy these days. Because I can't see where that would be worth my life, is to get to a concert or go to a something like that. No, I think I prefer the sanity of being at home and shopping from home. I think we've all kind of gotten that way these days, huh? Who would rather go shopping at Walmart versus just shopping on Walmart.com? I don't think any of us. Really? I spend way more money when I go inside. So then this is bleed off again. It's just always to pull any extra fluid off the system. You got any questions about all this? I said, the phrase that a lot of people use is when in doubt, meter out. Why? Well, I'll show you in a minute because I've actually got to go turn on the system. But meter out has the ultimate control. You can keep control of just exactly how fast that cylinder extends and how fast it retracts. I mean total precision control. So when in doubt, meter out is probably one of the most common phrases when you're designing these circuits. All right. So that being said, what time is it? Oh, it's only 2:30.